Hi, the doctor's in. I'm Dr. LB and I'm here to help you through your math difficulties. Today, we look at the general form of a quadratic equation. The general form of a quadratic equation or a quadratic function is f of x equals a times x squared plus bx plus c. In our last lecture, we talked about the standard form for a quadratic function. And in both forms, you have a vertex, which represents the minimum or maximum value. Here, we have a vertex formula. The x-coordinate is given by the value negative b over 2a. And then the y-coordinate is given by evaluating the function at negative b over 2a. X equals negative b is the axis of symmetry. It's a vertical line that goes straight through the vertex. And if your a is bigger than 0, then you have an upward pointing parabola, and you have your vertex being the lowest value on that graph. If a is less than 0, you have a downward pointing parabola, and you have your vertex being the maximum value. So how do we graph a quadratic in general form? Well, number one, does the parabola point upward or downward? Number two, we can find the vertex with the vertex formula. Or you can transform this general form into standard form. And you can easily pick out the vertex. And when you do that, find the x-intercepts by setting the equation equal to 0 becomes a little bit easier as well. Then you can find your y-intercepts by evaluating the function at 0. And next, you can plot the intercepts, vertex, and other points as needed. So we're going to look at a couple of examples. The first example is f of x equals x squared plus 4x minus 1. And what we're going to do is we are going to find the standard form for this function. Let's go ahead and do that. And we're going to be completing the square when we do that. What we need to do is to gather our x squared terms and our x terms together. Then we know that when we complete the square, the coefficient of x squared has to be 1. If it's not, we're going to have to factor that from the x squared and the x terms. But here it's 1. Then we go to our x term, which is 4. We take half of 4, which is 2. And we square 2, which is 4. So we're going to add 4 inside the parentheses. And here we're going to subtract 4. So if you add 4 inside the parentheses and subtract 4, you're really putting in 0. Now, if we had to factor out a number here, we would need to multiply that number by 4 to see what we really added. But once we do this, what we have created is a perfect square trinomial where this x squared plus 4x plus 4 factors as x plus 2 quantity squared, and that becomes negative 5. So now this is in the standard form. And we can easily see that here a is 1. So this parabola points upward. We can easily pick out our vertex. It is x minus h, but because that's a positive, we're going to take a negative 2 plus k, and that'll be a plus a negative 5. So k is negative 5. Number 3, we're going to find our x-intercepts by setting this equal to 0. So we have x plus 2 squared minus 5 equals 0, or x plus 2 squared equals 5. So x plus 2 is plus or minus the square root of 5. So x is negative 2 plus or minus the square root of 5. And we're going to get some decimal approximations for plotting. So we have 0.24 and negative 4.23. And our y-intercepts we get by evaluating the function at 0. Now, it's easier to look at the equation in general form to do that because the first and the second term goes away and you're left with -1. So let's plot this. We have a vertex of -2, -5. We have a y-intercept of -1. We have 0.24, very close to the origin. Then we have -4.23, which is somewhere about here. This parabola points upward. And that is the graph. So got another one. Now, this one's going to be a bit more complicated because here a is 3. So we have 3x squared minus 2x minus 4, and we want to get this in standard form. So remember, we're going to gather our x squared and our x terms. I'm going to write that 4 out to the side. And we said that, hey, to complete the square, we have to have a coefficient of 1 on the x squared. So I need to factor out of 3. And I'm going to factor out of 3 from the x squared and the x term. So how do I get what goes as our coefficient? Well, I do 3 divided by 3, that's 1. Then it's -2 divided by 3, it's -2/3 x. So here we're going to be dealing with some fractions. So I take half of -2/3, which is -1/3, and -1/3 squared is +1/9. So I put my 1/9 inside the parentheses. So what I've really put in is this 3 times 1/9. 3 times 1/9 is 1/3. So I really put in a +1/3, and I need to go over here and subtract 1/3. So we can rewrite this as 3 times x minus. Now the way you factor this is whatever half that number was, which was 1/3, that's how that's going to factor. 4 is the same as 12/3. So -12/3 minus 1/3 is -13/3. So what this means is, number 1, a was 3. So this thing points upward. Number 2, the vertex is the point. What? This is x minus h. So that's a +1/3 plus k, a -13/3. And in order for us to plot, let's go ahead and get a decimal approximation of 3.33 and -4.33. So next we need x-intercepts. So we can set this thing equal to 0. When we set this equal to 0, we will get 3 times x minus 1/3 squared. And I'm going to go ahead and take that -13/3 over and make it +13/3. Then I need to divide both sides by 3. X minus 1/3 squared is 13/9. Then I take the square root of both sides. X minus 1/3 is plus or minus the square root of 13/9, which is plus or minus the square root of 13/3. So x is going to be 1 plus or minus the square root of 13 all over 3, which gives us decimal approximations of 1.5 and -0.87. And number 4, to find our y-intercept, let's go back to our original equation, we evaluate f of 0, so the first and second terms would go away, and we're left with negative 4. So let's put all of this on a graph. Negative 3/3, that's a third, and negative 4.33 is about here approximately. The x-intercepts 1.5 and negative 0.87. It's about here. And then our y-intercept of negative 4, which is there. So this graph is pointing upward. Kind of a little skinny parabola here, but that's our parabola. So remember that Dr. LB is always in. Please come back for more math help.